Hello everybody, how are you? Hope all of you are well. And last day I discussed about symbol, and today I'll start from valency. Okay, now what is valency? Valency of an element is defined as the number of hydrogen atoms or halogen atoms or double the number of oxygen atoms which combine with one atom of the element. Or in the very simple way, okay, we can tell the valency is the combining capacity of an element with other element. Now, if we think about the water molecule, okay, in water molecule there is one oxygen atom and two hydrogen atom. So in water molecule, two atoms of hydrogens combine with one atom of oxygens. Okay, so to form a water molecule. So what will be the valency of oxygen? That will be 2. Here I can show you one model. Suppose this one is the water model. The red ball is the oxygen atom, and these two, that green, these two are hydrogen, and this oxygen is attached with the hydrogen with a single bond. Here also one single bond is there. Hope you will be able to understand. So in this case, as the combining capacity of oxygen with the two other hydrogen atom is 2, oxygen is attached with 2 hydrogen atom. So the valency of oxygen will be what? 2. But if you think about the hydrogen, what is the valency of hydrogen in water molecule? Each hydrogen is attached with one oxygen atom. So this hydrogen is attached with this oxygen atom, and this hydrogen is attached with this oxygen atom. Okay. So from here you can easily understand. So the valency of hydrogen is 1. Hope you can understand. Okay. Next we will take another example, that is the ammonia molecule. Suppose this yellow ball is the nitrogen, and there are 3 hydrogen attached with this nitrogen. NH3, formula is NH3. So here what is the valency of nitrogen? Valency of nitrogen will be 3, because 3 hydrogen atoms are attached. So these are the hydrogen, red balls are the hydrogen atom. So this one is the ammonia molecule, and this nitrogen containing one lone pair of electron. Okay, this is called lone pair of electron because it is not forming any bond and it is not shared. Understand? So this is the ammonia molecule. So here nitrogen valency is what? Nitrogen valency is 3, and hydrogen valencies are 1. One hydrogen is attached with one nitrogen atom. Next, we will think about that methane molecule. So this is the methane molecule, tetrahedral arrangement. Okay, so here carbon atom is attached with 4 hydrogen, and there is single bond between carbon and hydrogen. Okay, now this methane molecule you see properly. Okay, so here what is the valency of carbon atom? Carbon atom is attached with 4 hydrogen atom. Okay, so carbon atom, here 1 hydrogen atom, 1, 2, 3, 4. So 4 hydrogen atom is there. So valency of carbon will be the here what? Here valency of carbon will be the 4. Okay. Next we will think about the ethane molecule. So this is the ethane molecule. Carbon, hydrogen, 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 and carbon, hydrogen, hydrogen. Its formula is C2H6. So here carbon single bond is there, and carbon hydrogen. Okay, carbon hydrogen single bond is there. So one carbon is attached with 3 hydrogen atom, and this carbon is attached to single bonded to another carbon atom. And in the lower portion also there is 3 hydrogen atom attached with this carbon. So here each carbon valency is what? 4. So here 1, 2, 3. This carbon is attached to 3 hydrogen atom and 1 carbon. So each carbon valency is 4. Okay. So it's that carbon valency is 4, and its structure is what? This is 3-dimensional structure of ethane molecule. Understand? Next we will take another example. This one is ethylene molecule. Okay, here between two carbon one double bond is present, and each carbon atom is attached with two hydrogen atoms. So these are the two hydrogen singly bonded, and this carbon and carbon, in between these two carbon atoms there is one double bond, one sigma bond, another pi bond. Hope you can understand. So here also this carbon valency is 1, 2, 3, 4. So carbon is showing tetravalency, and because of this tetravalency and its catenation property, the number of organic compound is very high. Next we will go to the another example, that is PCl5. Here the blue ball is the phosphorus and it is attached with 5 chlorine atoms. So these are the chlorine atom 1, 2, 3, 4, 5, and these are called equatorial position and this is called axial position, and its shape is trigonal bipyramidal. So here this one is trigonal, above and below there will be one pyramid. So this is called trigonal bipyramidal, and here the valency of phosphorus atom is 5. Here 1, 2, 3, 4, 5. Hope you can understand. So this is your PCl5 molecule. Next we are coming to the another molecule. This is also, I think, PCl5 like. So we have to make one SF6 molecule. So here we can make. So now we are making. I am showing how we are making. So in SF6 molecule, definitely there will be 6 fluorine atom attached with 1 sulfur atom. All of you know the color of the sulfur atom is what? Color of the sulfur atom is yellow, and its structure will be octahedral. So here you see, this is the SF6 molecule. SF6 molecule, okay? See the structure. So here, these are the equatorial, 4 sulfur fluorine equatorial bond and 2 sulfur fluorine axial bond. So here sulfur is attached with 6 fluorine atom, okay, in the equatorial position 4 and axial position 2. So that is why the valency of sulfur atom will be what? It will be 6. So here valency of sulfur atom is 6. Actually sulfur can show different types of valency. It can show valency 2 in H2S molecule, hydrogen sulfide molecule. When sulfur is showing 4 valency, in sulfur dioxide is showing 4, or SF4 molecule is also possible. In case of SF6 or sulfur trioxide, the valency of sulfur will be 6. Hope you can understand. Okay. So next we will discuss the electronic concept of valency. The elements present in the outermost shell of an atom are called valence electrons. Okay, and the maximum valency of an element is equal to the number of its valence electron. Suppose metals. Okay, now if we look at the periodic table, then we can easily understand. So I have already told you, please purchase this type of periodic table and paste in your study room. So here this group 1 elements. So first one is hydrogen, then lithium, sodium, potassium, rubidium, cesium, francium. Okay, so here if you look at the valence electron, in each case the number of valence electron is 1. In outermost shell there is 1 electron. So that will show the valency 1. So sodium will show Na plus 1, so valency 1, potassium K plus, and lithium Li plus 1. And in the second group, okay, and first group is called alkali metal group, and second is the alkaline earth metal group. Here beryllium, magnesium, calcium, strontium, barium, radium is there. So here in each case the valency of this metal will be 2. Actually barium is forming barium 2 plus, magnesium is forming magnesium 2 plus. So in each case, as the number of valence electron 2, it will show the valency 2. And these are the, from group 3 to group 12, these are the transition element. Okay. So this transition element will show variable valency. Now what is variable valency? Variable valency means certain compounds will show more than one valency. Like iron. Iron will show ferrous and ferric. Iron +2 and +3. Copper will show Q plus Qp. Copper +1 and copper +2. Understand? And here also tin is there. Okay. Here this tin, these are not the transition element. Okay. It can also show variable valency. Okay. Later you can understand why it is showing lead, tin and lead. Tin can show +2 +4. Lead can show +2 +4. There is tin is stannous tannic and lead is plumbous pumbic. When there is lower valency, that is called As, and higher valency is called Ik. Like ferrous is +2 and ferric is +3. So lower valency is called As and higher valency is called. Now why they are showing? What is the cause of showing this variable valency? Okay, because in this case the ions of some electrons from the next cell, that is outermost cell, these electrons are coming, electrons are losing, as well as there is penultimate cell. From penultimate cell also they are losing electron. That is why they are showing the variable valency. Hope all of you can understand. And if we know the valency of the different types of elements, okay, and their ions, then we can easily able to write the formula. Now here you see this is the group 1. Group 1 valence cell, 1 electron is present. So its valency will be 1. In group 2 valency will be 2. In group 13 in valence cell 3 electron is there. So its valency will be what? Its valency will be 3. In group 4 in outermost cell or valence cell there are only 4 electrons are there for each element. So its valency it will show that 4. In nitrogen, phosphorus, arsenic, antimony, nitrogen will show the valency 3. Why? Because outermost cell 5 electrons are there and it will accept 3 electron to complete its octet. So that is why it will show the valency 3. Oxygen valency it will show that will be its valence will be 2. In water molecule we have already seen that oxygen is attached to 2 hydrogen atoms. So combining capacity of oxygen will be 2 and its valency is 2. And next fluorine, only 1 electron less from octet, so it will accept 1 electron, it will show the valency 1. And in case of this helium, neon, argon, krypton, xenon, radon, okay, so these are noble gas or inert gas, they generally not forming any type of bond, so their outermost cell is already complete, octet is filled up, that is why they will show the valency 0. Okay, so in their valence cell there are 8 electrons, but they will show 0 valency. Understand? Now we will tell about simple radicals. Simple radicals containing, first we have to tell what is radical. Okay, so what is radical? Most of the inorganic compounds, okay, made up of 2 oppositely charged particles. Okay, they are called radicals. And the positively charged particles or part, if it is positive charge, then it is called cation. If it is negative charge, then it is called anion. Positive part is called basic radical and negative part is called acid radical. Okay, for example we can tell that NaCl crystal, Na plus is present and Cl minus is present. So Na plus is called the basic radical and Cl minus is called acid radical. And what is simple radical? Simple radicals containing only one atom, like Na plus, K plus, Cl minus, H2 minus, these are the simple radical. Now what is compound radical? So compound radicals which contains atoms more than one element. Okay, suppose nitrate, ammonium, sulfate, okay, phosphate, PO4 3-, these are called compound radicals. So radical is defined as an atom or a group of atoms which carries positive or negative charge and behaves as a single unit in a chemical reaction. Hope you can understand. Okay, next we will discuss the chart of radicals. Positive radical, that means basic radical as well as acid radical. Okay, actually from where this basic radical comes? Suppose Na plus is basic radical. So Na plus from where we will get? NaOH, sodium hydroxide. So it is coming from the base. And acid radical, suppose Cl minus, it is coming from the acid HCl. That is why it is called acid radical. Hope you can understand. Okay, and when this acid and base will react, they will form the salt. Like HCl will react with NaOH, forming NaCl and water. And in NaCl also you will get Na plus, that is the basic radical, and Cl minus, that is the acid radical. Hope you can understand. So next we will discuss the different acid radicals as well as basic radicals. So generally monovalent radicals having a unit positive charge, okay, like H plus, and this is called hydrogen radical, H plus. Okay, actually H plus is not exist. Okay, it is not existing because here only one proton is there. Okay, so better we will write H3O plus, hydronia ion. Okay. Next we can tell that sodium Na plus, its valence will be 1. So these are the monovalent radical. Potassium plus, but next I am writing one basic radical containing no metal. So these are generally metal. This is also non-metal. And NH4 plus ammonia ion, here no metal is present. Although it is a basic radical, and here its valence will be 1, and charge is showing its valence. Okay. Suppose we can think about that Q plus. Okay. So Q plus will be Cu plus 1. That is valence will be the 1. Next one we can tell Aurus Au plus 1, Mercurus Ag plus 1. Okay, so in this way you have to remember. Next we will discuss that divalent radical. Divalent radical like calcium 2 plus, its valency will be 2. Magnesium 2 plus, its valency will be 2. So in this way there are different, like cobalt is there, cobalt 2 plus, ferrous Fe2 plus, magnesium 2 plus. Okay, manganese 2 plus, then plumbum, that is 2 plus. Okay, stannous, that is 2 plus, strontium 2 plus, zinc 2 plus. Okay, so here these are divalent. Okay, next we will discuss the trivalent basic radical. Trivalent basic radical we can write Al3 plus. Okay, that is aluminium radical. Okay, we can think about that arsenic, bismuth, arsenic 3 plus, bismuth 3 plus, ferric, Fe3 plus. So these are the trivalent radical. Antimony 3 plus, auric 3 plus. Okay, next one is the tetravalent radical having 4 units of positive charge. Here we can write that Pt plus 4, platinum plus 4, Pb plus 4, pambas, pambic. So this is pambic. Okay, Sn plus 4, stannic. So these are the tetravalent. So it is tetravalent radicals. Okay, C4 minus, that is carbide. So here also you have to remember the C4 plus, that is carbon. Okay, carbon radical. So here also you have to remember the name of the radical as well as its symbol and valency. Next we will discuss that pentavalent. Pentavalent we can write that antimonium Sb 5 plus. Okay, we can write that arsenic also can show 5 plus. Okay, next we will discuss the uni-negative or monovalent acid radical. Monovalent acid radical we can tell you first that halides. Halides are monovalent acid radicals like chloride, valence will be 1, bromide, iodide, fluoride. Okay, so these are simple radical. Now we can write the compound radical also, like nitrate, NO3 minus 1. So here 1. Nitrite, here also 1. Or we can write acetate, CH3COO minus 1. We can tell bicarbonate, bisulfate, all are acid radical and its valency is 1. Next we will discuss that divalent radical. Divalent radical we can write CO3 2 minus acid radical, CO3 2 minus, that is carbonate radical, its valency will be 2. Okay. Next we can write CrO4 minus, chromate. It is also divalent. Sulfate, SO4 2 minus, this is also divalent. Sulfite, so this is also divalent. So in this way different divalent acid radicals are there. So you have to remember the name and its formula and its valency also. Like sulfite, SULPHID, that is H2 minus. So these are all divalent. Okay. In case of oxalate, this is also COO minus, COO minus. So this is also divalent acid radical. So in this way you have to remember this divalent. Oxide, O2 minus, this is O2, peroxide, O2 2 minus. Peroxide also divalent acid radical. So this thing you have to remember. Zincate, ZnO2 2 minus, this is also divalent acid radical. Next we will discuss the trivalent acid radical. Okay. First we can tell you that N3 minus, nitrite. So this is the trivalent acid radical. Hope you can understand. Phosphide, P3 minus, ALO3 3 minus, ALO3 3 minus, this is the aluminate. Okay, borate, BO3 minus, BO3 3 minus, this is also trivalent acid radical. So in this way you have to remember trivalent ferricyanide, FeCnL whole 6 3 minus. And next tetravalent we can tell you that C4 minus, that is carbide, C4 minus. Okay, ferrocyanide, FeCnL whole 6 4 minus. Once you remember this type of acid radical and basic radical, their valency, then the writing of chemical formula will be very easy. Okay, so first you try to remember this acid and basic radical list. Okay, and next day we will discuss that how to write chemical formula. Okay, so again I am telling this writing, remembering of these different types of acid radical and basic radical and their valency is very much important. Without this you cannot able to learn chemistry properly. So when you will be able to write these radicals properly with their valency, then you will be able to write the chemical formula. And next, if you are able to write the chemical formula, you can write the chemical equation or chemical reaction properly. Then you have to do the balance. If you are able to write the balanced chemical equation, that means that your chemistry is 50% ready for exam. Okay. So be serious about this chapter. This chapter is very important. That is why it is given as your first chapter. Without the knowledge of language of chemistry, you cannot learn any chapter properly. So hope all of you enjoyed my class. Okay. And today up to this, next day we will discuss more. Thank you.